The idea is to speak about different matters which are related to science, and so to say, scientists, academics are giving talks to other academics. And this our seminar now starts to be supported also by Simon Foundation, and it is together with Lviv Scientific Society, ЛьВІВСЬКе товариство науковців. Today I have a pleasure to present you my colleague, our colleague from Vienna, Daniel Kondor, who is from Complexity Science Hub Vienna. That's an international institution which is, you see from its name, it's about science of complexity in different incarnations, complexity in natural phenomena, complexity in social phenomena, complexity in economy, and so on. And Daniel did his PhD in Budapest, and his background is physics, but physics which is also connected with data mining and with network science, so very interdisciplinary physics. After PhD, he stayed in several institutions. One of them is Sensible City Laboratory in Massachusetts Institute of Technology in the United States. Another one is Smart Facilities Management, which is in Singapore. And since 2021, he is in Complexity Science Hub. So today he will be speaking about the topic which is connected with history. But if you look on the papers he wrote, and some of them I read, you will find papers about Bitcoin transaction network. Another paper I saw was about mobility and how this human mobility is influenced by spread of diseases. So very different phenomena, but for us, for those people who are dealing with complexity, they are also very similar. So generally speaking, he is interested in various topics that focus of analysis of large-scale, geographically embedded phenomena. If you put it this way, so all these topics are very tightly connected. So with all this said, I am very happy to pass the stage to our today's speaker and to thank him for coming to join our seminar. You are welcome, Daniel.
Yeah, thank you, Yuri. Thank you again for inviting me. Let me try sharing my screen and show my slides. Okay, so again, welcome to this talk where I will be talking about quantitative modeling approaches to understanding some processes in history. The high-level name of this field, this emerging field, is Cliodynamics, and a general motivation is looking at and making sense of the complex and sometimes scary processes that we see, and also thinking about how humanity can better deal with the global challenges that we are seeing, which include, of course, climate change and partly human-induced disasters, social unrest. So in this talk, I will start by introducing the concept of complexity, and then a bit general context about what we can do, data-driven approaches for studying history. Then I will focus on the research of my colleagues at Complexity Science Hub and globally about identifying and trying to explain some long-running trends. And finally, I will focus on my own research about European prehistory and how we try to connect small-scale local interactions to large-scale outcomes. First of all, as Yuri mentioned, I work at the Complexity Science Hub in Vienna. Oh, sorry, before I get into the topic, here I only see my screen, so I don't see any of you, but please feel free to interrupt me. And if you are trying to interrupt me and it's not working, just try to speak up, or Yuri also, please.
Okay, I will
if you see
follow. I
some-
will follow, and if there will be some questions, I will interrupt you, and then you will get the question. Okay, thank you.
Yes, yes, very, very good. So I work at the Complexity Science Hub, which is situated in this nice old palace in Vienna. Yuri visited us several times. This is a very interdisciplinary research institution where we have many different topics that all try to approach one or many of the big challenges facing humans. And we are trying to use a data-driven approach and quantitative approaches to address emerging global problems. So this includes topics about the economy, about society, about health, and a lot of things. If you're interested in learning more about Complexity Science Hub, we have a recently renovated webpage, and there are many visual introductions to the projects done by my colleagues. And within Complexity Science Hub, I'm part of the Social Complexity and Collapse research group, which is a relatively small research group with a few of us on the top row working at CSH, and we have many collaborators around the world. Only some of them are displayed in the bottom, who I work more closely with recently. The group leader is Peter Turchin, who has been for decades trying to study history with quantitative methods and with data-driven methods. And I will talk a bit about the general picture, but before we get to that, what do we mean by complexity, as in Complexity Science Hub, or as in complex systems? And the very general answer is a complex system which is more than just the sum of its parts. So what does it mean in a bit more detail is that there are many interacting components, and these interactions are essential for understanding the behavior of the whole system. So we cannot just abstract them away. Complex systems often have emergent behavior, which is something which is not obvious or maybe even counterintuitive based on how the individual components behave. And examples are maybe the weather, maybe markets, or social networks, or even supply chain networks that now go around the globe, and our lives usually depend on them. So how we can try to understand complex systems, especially when thinking about methods of quantitative methods and natural science. And just a very quick overview of the progression of thoughts. So in the 19th century, in classical physics, so as Yuri said, I'm originally a physicist, so I still think like a physicist, and I try not to pretend I'm something else, but even when I'm studying topics outside of physics. So in the 19th century, many scientists had this mechanistic worldview where everything is deterministic. If you can measure the system well enough, you can predict outcomes. And then in the early 20th century, at least in physics, there were discoveries in quantum physics which showed that if you, in deep down, everything is fundamentally random and fundamentally unpredictable, but still systems based on quantum systems can be predicted when you go to the macroscopic scale. What was more important later in the 20th century, the discovery of chaotic systems which are fully deterministic, and yet predicting their behavior is impractical. Even so, if you know everything about them, you can predict their behavior. But the fact that in reality we cannot know everything about a system becomes a big practical hurdle in predicting them. Yet there are treatments which show that even though predictions in chaotic systems are difficult or sometimes practically impossible, we can learn about chaotic systems, understand something about the structures and understand what are the important interactions, what are their important properties. How does this relate to human behavior or human societies, human history? I mean, there is the philosophical question if human behavior is fundamentally unpredictable or not. But if we apply the theory of chaotic systems, this is not the most important practical question. We know that even if there would be a theory of predicting human behavior, we couldn't do accurate predictions on a large scale. So the question is how we approach this as a chaotic system and still learn something that reveals what are important fundamental interactions, which in some way might still be useful to learning about what outcomes to expect. And then how do we apply this perspective to history? And some general points. One of the things we can do is focus on long-term emergent processes and just try to identify what are the fundamental interaction mechanisms that contribute to them. So we maybe abstract away details, but see that even on this abstraction level, we might be able to connect interactions to outcomes, at least in a statistical sense. Also, we can understand that outcomes come from collective behavior. So better understanding of human collective and group behavior will be a key. We also have to deal with limits to predictability and limits to what we can explain. And also, we have to engage a lot with existing theories of history. And existing theories of history are often what set of logical steps, not equations or measurements or data behind them. And the big question is, how do we connect this traditional historians' thinking to natural scientists' quantitative thinking? And one thing that's very important, that as natural scientists, we have to be modest and understand that not everything can be easily quantified. And one of the questions to ask, what we can quantify and what we can measure, and then what we can predict or at least explain based on this. So the next question is, what do I mean by modeling? So as I said, we try to do quantitative models, sometimes statistical models, sometimes agent-based models. My focus is mainly on agent-based models. And what we need to understand that a model is always an abstraction of reality, and sometimes a very coarse abstraction. So what I'm showing here is a picture that one of my teachers showed me in an agent-based modeling course I took a very long time ago, which is a very famous painting, of course, by René Magritte, which is a picture of a pipe with the caption that this is not a pipe. And what he might have meant is that this is an image of a pipe. What I might say is this is a model of a pipe, which shows us how a pipe looks like. And the question is, okay, this is a model, but is this a good model? And the classic answer is all models are wrong, but some models are useful. And to illustrate this a bit more, here I'm showing two models of Roman emperors. And you could ask which of these models are better. And there are many ways to think about better. You might say the left one is better because they did a nicer job to make the subject more beautiful, more nice looking. You might say the right one is better because it's a more realistic. We don't believe the guy on the left was so handsome, and maybe the right one shows something more real. Then some people might object that actually this is just a style, and the right one is intentionally made uglier to make it more relatable. But then if we think a bit what these statues, models represent, we might realize we don't really care how these people look like. And maybe even when these statues were made, most people didn't care how they looked like. Most people wouldn't meet the emperor in person. What we might care, what these representations tell us about how they thought about being an emperor, being a ruler. So in this sense, when we are trying to build models, we care less about how our models look. We care less about how they represent all of the processes, but care about if we can capture something useful that tells us something new about the system, the complex system we are studying, in this case, history. So with that said, I'm first going to talk a little bit about research done by my colleagues, by Peter Turchin's group in the past decade, about collecting data, organizing data, and trying to identify long-term trends and maybe explain them. So what is the big motivation is what we might label as the Great Holocene Transformation, which is a huge increase in the scale of human cooperation, going from small-scale communities to nation-states of billions of people and global corporations and global supply chains nowadays. Of course, not all of this cooperation is necessarily voluntary, but it still shows that there is a scaling up process. Nowadays, we depend on millions or potentially billions of other humans for all of the goods and services we need for our survival. We are, in some way, you might say we are cooperating with billions. And also, if you look at it, look at a longer time scale, this transformation happened after humans already existed for probably more than 200,000 years. So humans lived for 200,000 years in small-scale communities with no consistent large-scale political organization. And then something started, and we ended up with information communication and economic networks spanning the globe. So one goal of this research was just to characterize this process, and then the next goal was try to represent theories that people already made about this process, and also try to test them with data-driven methods. So how to characterize these long-term changes, especially when we are thinking about social organization? We can think of the complexity of social or political interactions, and we can think of complexity in terms of intentional complexity, the institutions that humans create, which tend to be more and more complicated over time. So here on the left is institution how to become the ruler of Egypt 5,000 years ago. On the right is the very abstract institution how to become the leader of Germany nowadays. Or we could also look at emergent complexity, where local and small-scale interactions lead to something larger scale that will still affect all of the participants. So what is one component of this research is the Seshat data bank. So this is a very large project that has been going on for 15 years, I believe. And it's like much longer since I joined this team. And it's a large-scale effort to collect facts about history. Now it has over 45,000 data points, and organize them in a way that these facts can be analyzed by computers. So we can write programs, we can write statistical analysis methods that will identify some patterns in these facts. Importantly, so data collection took a lot of time and took hundreds of contributors. So main data collection is we and our collaborators hired research assistants to read articles about history and answer questions about facts. And other experts checked these answers. And also the process started with first formulating the questions by a set of historians, archaeologists, and scientists, natural scientists, to identify questions which will hopefully capture important emergent processes. Some of the topics are shown in this figure. These are typically simple questions. If at some time and some place they had a certain type of institution, certain type of specialized profession, or a certain type of technology. Actually, to illustrate a bit more, I have an example of the database. So now the current version of the data is available online at seshatdb.com. And for example, I go to archaic Crete, and we have a description, which is about the context. And we have a bunch of general variables that sets the context. And then we have some specific variables that tell us either quantitative or sometimes just yes, no, an absence or presence of something. So for example, here, based on history and archaeology knowledge, someone identified that in this polity, which is archaic Crete, the largest settlement was only about 4,000 people, but then they had full-time
Excuse me, may I interrupt you?
Yes.
Where is the time? Somehow in each of these boxes there are samples of different time.
It's
Where
one
is the
time
variable?
So this is here. So for each polity, we have a time which was identified first as the so first how these were generated is set of Seshat experts looked at world regions, selected a location which we know had interesting things happening. I mean, most places around the world had interesting things happening, but a place where we know we will be able to find these facts, and then did a characterization of time periods, which was then refined based on the literature. So each page on our database page refers to a specific location at a specific time, and then all the facts and all the questions answered. And for each fact, we have a short answer which can be processed by a computer, and then we also have a long answer, which is the justification for the short answer. And if you return to the main page with the listing of the polities, now we have the links to all the individual pages that collect the facts for one specific place at the given time. And these are also organized by location. And we have the original sample, which has a lot of data, and the database is of course continuously evolving, and there are projects to add more and more data. So interestingly, this results in a computer readable data set, and then we can do further quantitative analysis. So one interesting result, which was done in this article already many years ago by Peter Turchin and his team at that time, is to do a principal component analysis on combinations of variables. And what they found is most variables are well correlated. So they said that there is one emergent measure of social complexity that captures most of the variation in these facts, in things like absence or presence of institutions, technologies, and also the quantitative measures such as the size of settlements or size of polities. The next question was, what might be the interactions that drive these changes? So we see that the long-term patterns are a growth in this complexity measure. Of course, it's not a strictly monotonous growth. There are declines, but the overall trend is growth and this is consistent with the general motivation of scaling up of cooperation and complexity over time. So the next step was to test causal relationships between these variables. So test how change in one variable affects other variables sometime later, and also relate these to existing theories, which some of them are listed here, short names, but there is a article detailing a lot of them. So variables were linked to existing theories and existing hypotheses. And what they found is the main driver of this increasing complexity over time is, first of all, having access to agriculture and having had agriculture for a long time. And second of all is having access to increased military technologies and having some form of increased competition between neighbors. So this results sends maybe a not very nice message that competition and violent competition was often a driver of political changes as well in history, and that I think also tells us that there is a lot to think about how to maybe change this pattern in the future. So that concludes my overview of the larger scope of the projects and the look at long-term trends. And now I want to talk a bit about a very interesting topic, which is looking at the prehistory of Europe. So looking at the starting point of changes when people just started practicing agriculture and mostly still lived in small-scale communities. So this, what you see here, is just a rendering of or an artist impression how Europe might have looked like 7,000 or 8,000 years ago, with mostly still pristine landscape and some small settlements surrounded by fields. So this is the period of the Neolithic, which literally means New Stone Age. So there is already agriculture, mostly farming and some animals, no significant use of metals. And in Europe, agriculture came with farmers migrating here from Anatolia and the Middle East. There are no large-scale states, no signs of consistent large-scale entities, no signs of consistent political organization. People are living in local communities, but maintain trade and cultural links in relatively large regions. And what is very interesting, there is a increasing amount of evidence that population and settlement changes were very dynamic. So you might imagine, and I imagine, that what happened is people settled in a village and lived there for 3,000 or 4,000 or 5,000 years, and nothing interesting happened. And then sometime later the Roman Empire came and made a city or a province, but this was apparently not the case. What we see, so this is a characterization of the initial migration of farmers into Europe, and after that, what we see, if we look for signs of population, number of settlements, number of houses, number of archaeological finds per region, is that there are relatively large up and down turns. So people come and settle in a region, spend a few hundred years, and then many times after that came a downturns, and settlements disappear or evidence is lacking, and then later there are new settlements with a different culture coming up and popping up. So also there is speculation that the scale of political organization was changing, but still quite small scale. So maybe a few groups aggregated into local collectives, but nothing large scale. Also, there are some people trying to estimate the extent of settlements at different points in time, and we get these very interesting shifting patterns. So what we get from looking at archaeological databases, which sometimes they include settlements, often they just include individual finds and their approximate dates, which then we can use as proxies of population size, is that we see dynamic patterns with temporal scales of several hundred, 500 or even 1,000 years. So there is a growth for a few hundred years and then a decline for a few hundred years. And the spatial scale of these patterns is several hundred kilometers. So there is something happening on large scale. So this is not only something which you might explain by what happens within one group or within one village, because there could be many reasons for just abandoning one village, but this happens in regions. So what we see emerging is much larger scale than the assumed interactions. So this leads to questions. What could be the underlying interactions? And of course, many possible explanations were proposed. Some people proposed it could be mainly the effect of climate changes, so that as climate is still changing in this period, some regions become more friendly to habitation, some regions become less friendly, and the occupation and population follows this. Some say it could be just external, that who could migrate to Europe at what time, and there are hypotheses of mostly internal endogenous interactions about change of social integration and disintegration, about environmental feedbacks or the emergence of diseases. So in this research, we focused on climate, we focused on social disintegration and conflict, and we focused on ecological feedbacks, exhaustion of soil fertility, but I'm not going to talk much about this last one. So how do we approach this? So in this case, we do build an agent-based model. And as I said before, our goal is to build an abstract model which has a simple representation of this time and space and captures some essential possible interactions. We want this model to be able to generate time series of regional population dynamics so that we can identify statistical properties, identify what are the time scales of growth, decline, what are the spatial scales of patterns, and then compare these to real-world population estimates, or I shall say population proxies from archaeological data. So just as an aside, what are agent-based models? And I'm not going to talk much about. I will try to illustrate our agent-based model in a way that is understandable. But if you're interested a bit more in the topic of agent-based modeling and the wide range of things that agent-based models can be used, I can recommend maybe these two resources. On the left, CSH, we have an explainer for agent-based modeling, and on the right, Dirk Brockman's group has a very nice website with a large set of models applied to a lot of complex systems in a lot of settings. So then back to what is our model. So the main idea with agent-based modeling is that we want to create interactions among many discrete units. In this case, one agent is one independent village. So we are not trying to model what happens within a village. We are not trying to model independent persons, but we say that since the scale of organization is at maximum village level, we will model what villages are doing. So this is, of course, an abstraction. And then we create a simulation space by dividing Europe into a set of discrete cells. So each cell can be either empty or occupied by one village. And to be able to model population growth, but also the effect of climate, we estimate agricultural productivity in each cell based on modern data, but also reconstruction of climate going back a few thousand years. And then we run this model in 1 year time step. So in each time step, we go through all of the cells. We simulate interactions within each cell. So within each village, we just have a few basic rules which tells us how the population of that village changes, and also whether that village decides to do some interaction with their neighbors. And then we simulate these interactions between villages. So what are the main interactions that we want to put in? First of all, there is the interaction with the environment. So as I said, agricultural productivity changes based on our reconstruction of climate patterns in this period. That changes how many people each village can support. That drives our population processes within a village. So villages' population can grow if conditions are good, and it can decline if conditions are bad. Then we have a social process where if a village gets too large, people might decide they want to split. Some of them want to leave and settle in an empty cell. So this is a main component which represents that people try to avoid too crowded conditions. People try to avoid overloading their local environment, and also that as groups get bigger, there is more chance for social tensions. Also, there is a lot of evidence and theory about continuous onward migrations being an important cultural component, at least in the early Neolithic cultures in Europe. Then the most important part of the simulation is capturing and simulating what happens if a group wants to fission. And we have a module which tries to find an empty cell. If they find an empty cell, that's very good. They just move there and found a new village there. If they are unable to find an empty cell, they might decide then instead to get into a conflict with one of their neighbors. So what this means that if a region is more densely settled, we will start to see more and more of these conflicts initiated. But then the further important component is that conflicts not only have immediate effects, and I'm going to talk a moment later what are these immediate effects, but these conflicts lead to cultural changes. Some groups adopt a more aggressive outlook and get into a tendency to get into more and more conflicts with their neighbors, even without the fissioning interaction. So then what is the outcome of a conflict is some people are killed in it and some people decide to run away. So what happens is that areas affected by conflicts can be abandoned if conflicts are persistent. And putting everything together, this model will have two types of negative feedbacks. First of all, we have the external negative, and it's not really a feedback, an external negative effect, which comes from climate variability. And we have a negative feedback, which inside a village, the limit on local resources leads to group fission. And on a regional level, running out of empty space leads to conflict initiation and eventually the abandonment of regions. So I'm not going to talk in too much detail. This just gives a general overview of how we are trying to build a model and the main ideas represented. So what we do next is run the model. We run it many times for many parameter combinations. And the main outcomes we are trying to get is regional population time series. So this is an example. We divide Europe into approximately 500 kilometer by 500 kilometer regions. This is just one example. We, of course, experiment with shifting this grid into multiple places to not have effects just based on the location of grid cells, and aggregate population numbers over time. So here, this is just one example simulation, and what we see indeed is we have periods of fast growth and periods of fast declines. And then what we do with this time series is that we extract the main temporal patterns by looking at the autocorrelation in each of the regions. And in this case, what we see that we have a typical time scale of 500 years, which means that typically a minimum follows a maximum by approximately 500 years. So just to give a better idea, this is an example simulation. So each grid cell is either black if it's empty, blue if it's occupied by a peaceful group, or red if it's occupied by a more aggressive group. And we see waves of settlements, conflicts breaking out, people moving out of those areas, and then resettlement of empty areas. So then what we do in the end is compare results to real-world data. And what we use in this case is a data set of radiocarbon dates for Europe. So a radiocarbon date represents one specific archaeological find, which was dated in a laboratory. And these are used as a proxy for human presence. So the idea is that if more humans are present in an area at some time, there will be more objects and artifacts left behind. More of these will be found and dated. So this gives us a very coarse estimation of regional populations. And in this case, since our model is also abstract, we are not really expecting to match exactly what happens in any region, but we can test if the temporal patterns of the real data and the simulations match each other. So we are, of course, experiment with multiple schemes for aggregation and for detrending the data. And this is just some of the regional time series in the real data set based on radiocarbon dates in the same regional aggregation scheme. We see many regions have a growth which represents just settlement of the region and growth of settlements. And then many regions have this up and down pattern where there is an initial settlement, and after that, some time there is a decline or abandonment. And then again, we calculated autocorrelations and look for the typical time scales, the typical time between peaks and minimums. And then how can we more directly compare? Is we can only do a comparison in a statistical sense. We identify the first minimum of the autocorrelation function in the real data time series and in our simulation outputs. Also, we do this for multiple grid locations and aggregation schemes. And then we get these histograms, which you see in the bottom row, about the what we call typical timescales of processes. And then we compare. Gray is the distribution histograms from the radiocarbon dataset, and red is our simulation outputs. Also, we do something similar for the coefficients of variation, so the scale of up and down turns. And then on the left, we do a comparison for model with conflicts. And on the right, we do a comparison with models where populations only follow changes in climate. And here, even in the time series, we see that we do see downturns, but those are short term, and this is confirmed by the autocorrelation where typical timescales are much shorter. So with this, I come to the summary of our study for Neolithic Europe. So we found that climate variation is not enough to explain by itself. It's not enough to explain population dynamics. Typically, what we get is short timescale events. We have a model of density-dependent conflict that can reproduce correct timescales and amplitudes. An important component that conflict is dynamics. We have social attitudes that change between peaceful and violent, and these change in response to local conditions, which are the density of settlements. And we don't have detailed mechanisms for these conflicts. And we are in the process of publishing. Well, we published one article about the model, and we are in the process of publishing a second one, which elaborates on the consequences of these conflicts. But still, we cannot model in more detail how these come to be. So, more generally, what we might get from this is that humans, I believe, have formed complex systems by collective behavior since prehistory. And especially the results for Neolithic Europe tells us that even in a case where we don't characterize as having a complex social, economical, or political system, at least not intentionally created, still results in an emergent complex system, which with outcomes on much larger scales than the interactions. So this also means that even though these early farmers might only interact with their neighbors, they are affected by processes happening on much larger scales. Also, this and the study of long-term trends and the session data shows that competition and cooperation are strongly linked. And in general, we need to be more conscious about complex outcomes coming from, in a way, simple interactions between individuals or in the case of our model, agents that represent small groups. And generally, quantitative analysis of history is hard. There are many difficulties. There are many difficulties in collecting data, organizing data, thinking of what is valid data, but can be a tremendous resource in understanding and separating universal and particular aspects of human behavior. We need to be more conscious about important components of human behavior. I know many people like to talk about what is the universal or what is the natural behavior for humans, but I don't believe I don't think we still have a good understanding of it. So we need more research, and in general, I think we need to be more self-conscious and self-understanding about human collective behavior. So thank you very much, and I'm happy to try to answer your other questions.
Thank you very much for your talk, Daniel.
Okay, so I try to.
So,
okay, I can see.
Are there any questions? Yeah, now you see us. We see your screen still.
Yes, I do see you.
Okay. So maybe while people are thinking about their questions, I must admit I have plenty of questions, so I will try not to put all of them. Just to start from the beginning, when you spoke about social complexity as a measure of to characterize as long-term changes, how do you quantify it? What is social complexity? If I dare to ask, you know.
Yeah. So
what is yeah.
What I would say, I would say there is not necessarily one measure of it. Right. So I think more important is the question: what can be a useful measure? And one useful measure could be the scale of cooperation. How many people cooperate on in a specific or general way? And again, I have to stress this doesn't necessarily mean voluntarily cooperation. You might say that I, in some way, cooperate with the factory workers who made my laptop, probably somewhere in China. And without that cooperation, we wouldn't be sitting here and discussing things. So that is an important property nowadays, that there is a form of cooperation on the scale of billions. But also what the Seshat, yes, what the Seshat project did is collect a set of measures about historical societies, and what was found based on these measures, and this was a bit surprising to the team at that time, is that there are very strong correlations, and most of the variance in this data set can be explained by just one principal component. And then they said, let's call this principal component a kind of social complexity. So that's another approach. And finally, what I might just add, that saying social complexity is, of course, not a value judgment. So we have to be very careful. This is a technical term that hopefully captures something important, but it doesn't necessarily say that a time or a place where this measure is higher is automatically better.
Yeah, thank you. Maybe I put another question, and then I ask the colleagues to put their questions. I'm not sure how to formulate it. Maybe you help me. You know, I was thinking from the point of view of physics. And then, you know, in thermodynamics, in phenomenological description, I usually to get characteristics, to get an energy, I would have two variables. One is extensive, another one is intensive. right? Volume, pressure, entropy, temperature, so on. Now you spoke about social complexity. And on the other hand, you spoke about agricultural production. You spoke about military warfare and so on. And then I thought maybe, and then you put this question that these are evolutionary drivers. So very simply speaking, say agriculture is influencing social complexity.
Yes.
And then I thought maybe other way around, maybe social complexity is influencing agriculture. And then I thought maybe my question is, you know, what was the first, the egg or the chicken? Maybe it is mutual interaction. You know, and then I am back to thermodynamics. We have generalized coordinates and generalized forces, and they are connected by Legendre transform. So you can change either one or the other one, depending on the process which you are describing. Is this very loose analogy? Does it capture something about what you were talking?
Should
I formulate this more precisely, or even for myself, it's hard to formulate? Simply, I say it is no difference between generalized coordinate and generalized pressure and generalized force. It depends on the process. And now we speak social complexity, agriculture, military, you know, warfare, and so on. And what are the drivers? And I say it depends. Maybe social complexity influences agriculture, or maybe agriculture influences social complexity.
Yes, so I think there is a more practical question and a more philosophical question. So for the practical question, as far as I know, how Peter's team tried to deal with this is doing regressions among variables, but not at the same time, but with introducing time lags. So then you would get a very practical measure of causality. And then the measures they have, so this figure is a causal chain, do have multiple directions. So they actually have an arrow here where social complexity does influence agricultural productivity. So there seems to be, and then they have a bigger feedback loop with warfare, and this seems that there is probably a process with multiple feedbacks, which is started somehow, and many of these influences might not be also not direct deterministic influences, but on the other hand, some of them can be thought as limitations. So, for example, one of the ideas behind the importance of agriculture in the original theories say that without largely productive agriculture and without agricultural products that you can store in bulk, it's very hard to organize a large-scale state, because if you don't have a granary that you can fill with 1 or 2 years food supply, then everyone will be preoccupied with thinking about how they secure their own food source, and then there are interesting, and there's this interesting trend that larger and larger polities appear where you have this kind of agriculture, and then there is the interesting outliers where people without agriculture but very productive resources, such as the indigenous populations in Western United States who have very productive salmon fishing, develops some kind of larger scale politics. But this is the practical part. The more high level part, how you relate these variables, like in thermodynamics, I'm less sure. I like the analogy, but I'm I cannot answer if it goes more than an analogy.
Yeah.
But this is certainly a very interesting point.
Thank you. Are there any other questions? Yes, please.
Thank you, Daniel. I'm deeply sorry. I came almost on conclusions, but in conclusions, I saw very familiar for me words like competition and cooperation. And I do economic analysis, economic research, and these both words sometimes are combined in co-petition as a way how business do things. And there are some evidence that smaller companies they rather want to compete to become bigger, so they try to divide pie, while bigger companies try to increase pie, to cooperate when they're already big one. So do you see in historical perspective the same behavior within society, say how small groups and large groups behave? So this is one question. Another question, again, it relates to competition and cooperation, because again, in history of economic sorts, the biggest discussion is between Keynesians and those who prefer Hayek and his theories. So Hayek promotes competition and libertarian economics as the main drive for economy to grow, while Keynes this state influence of the economics. So, and we had a long period, including COVID, when our governments pump a lot of money into the economy. And now, actually today, there was a big article about that in Financial Times, that we lack competition now. So again, do you see any analogies of current situation with historical perspectives you study? Thank you.
Thank you. That's a very good question, but it's a very difficult question. So what I can say that the results of my colleagues are in aggregate. So they didn't in this case disaggregate to what smaller or larger states do. What I can say where some form of disaggregation happened is I have a colleague who was building an agent-based model of the interaction of large agricultural empires and the nomadic people who live on their borders. And there, his conclusion was that this is a special form of competition which drives how the empires need to scale up in size, in productivity, in political organization. But this is on the other hand too specific. So this is I think a good question for future work. Regarding your second point, I think what I would maybe warn about when thinking about the connections, like the analogies between economics and politics, is that when we look at history, most of the competition between states was often violent competition. So this is a big warning when you think about how much competition you want in a system. Maybe I think nowadays the better question is how to find the right avenues of cooperation. And the sad conclusion is that since the two are linked to some extent, it might not be possible to cooperate well enough globally if there is no other entity left to compete with. And that's a bit depressing conclusion, and I don't think anyone has an answer to this. I think this keeps coming up, or maybe in the past decades, think like after in the 90s, there was this general optimism about the end of history, but it seems not happen. So here I don't think I can give a very good or productive answer, more like a warning or depressing answer.
Thank you.
Are there any other questions? Maybe from online? From online participants, I see there somebody rose a hand. Yaroslav, please. I don't know who is there. I see Yaroslav. Please put your question. Oh.
Yeah, please go ahead.
Maybe
I also see a raised hand, but
now
we
your
don't hear
microphone
you.
is muted. Yeah, please speak now. Somehow you don't. If the question is short, you can try to write it in the chat. Otherwise, I see your microphone is unmuted, but we don't hear you. It's a pity. So then I put my another question. That's about your simulations. You put your agents on the map of Europe, and then they were interacting. To which extent this embedding is important? Why not to use just square lattice, for example?
That's a good question. I mean, it's a technical question, and we were debating what kind of lattice to use. So what we wanted to have definitely is have a connection to real space. So we wanted to be able to run the simulation in real Europe, to be able to incorporate geographic features and incorporate estimates of agricultural products. So we wanted to have Europe, and then we were thinking of using a simple square grid, but stretched on Europe. But then we were unsatisfied that this limits us too much. We also gives a distortion, so we choose this hexagon grid where each cell is exactly the same size, regardless where it is on the map. And also, on the other hand, the shape of the grid doesn't matter. So I didn't have time to go into the detail, but interactions can happen not only between nearest neighbors, but to some distance. So the shape of the grid doesn't affect results that much. And then we have found this hexagon has nicer properties. So that's
Yeah, thank you.
Thank you. I see one more raised hand.
Yes, please.
Julian.
Please put your one question online and then a question from the audience. Please, online question. I see somebody rose the hand. The hand, I don't see who.
Yes, it's Julian Honchar
Yes,
from
please,
the Institute of Condensed Matter Physics. Yes. I wanted to ask the question that was inspired by the book The Horse, the Wheel and the Language about the Proto-Indo-European cultures. Because there it is said that the trade, or more not the trade, but the distribution of goods, and especially the distribution of valuable items like some gold or silver tokens of power, can come either in trade or in some conflict. And do you know any sorts of simulations or maybe historical research about this distance that the trade is, the good is traveled, or the distance of distribution of some specific valuable item before, in the prehistoric times, let's say, because later everything comes together and everyone has everything. But as it begins, as like the first time, for example, someone has this type of pottery, or the first time someone has this gold token. So do you think it could be another variable to look at different than population size.
Daniel, before you start to answer, may I ask you to stop sharing the screen? Then we will see all participants, because now the screen you share is frozen. Yeah, thank you.
Oh.
Please proceed. Yeah, thank you.
Yeah. Okay, so thank you for the question. It's a very good question, and I would say that during the Neolithic we do have some data about the transportation of materials, trades, but also the cultural interactions. So this was not included in our current model, but we are kind of actively working on extensions that would more realistically try to treat long-range interactions. But it's not easy because the data is not that large scale. So what we know that during the early Neolithic, so even before metals, people did trade relatively long distances, so 100 or 200 kilometers. What we see is there are special types of stone. So this is what was something like a surprise to me, that when you talk about Stone Age, you think all stone is the same, but apparently not. There are more valuable types of stone like obsidian and chert, which sometimes worth trading for 100-kilometer distance from special sources. Then at some points in time we see special items, for example the shells of clams, shellfish from the ocean making their way into Central Europe, or at least places in Germany, which can be interpreted as prestige items, but there is a debate. Some archaeologists say they were really traded as valuable. Some say that these were just more like souvenirs for people who made a big journey and brought to them, or others say that can still signify prestige because I can show off that I got this clamshell from the ocean. So there are evidences of objects traveling even in the Neolithic. On the other hand, what you mentioned is about the pottery. That's very important because pottery is the artifact that most easily survives. And what is apparent that at the beginning of Neolithic, groups across Europe in very large distances from each other keep making pottery of very similar styles. So it's not that they traded these vessels, but it's more like that potters in like maybe in present-day Vienna, where I am now, and in Western Germany, made vessels of very similar styles, which means that they had some connections. There are speculations that how people teach each other to make pottery was a specialized craft, and craftsmen traveled and taught people everywhere, or that how you decorate these pots was an important part of identity. And later, actually, we see more regional and local styles emerging, and then people speculate if it is about the breakup of this continental or half-continental identity. And there are many theories of the social processes behind, but not anything very conclusive.
Thank you. Please, another question.
Thank you for your talk. So I have a question concerning complexity and simplifications. In fact, I'm not sure that everything is going in the direction of making more complex things, because, for example, in dress, all of us are dressed in this way, and 300 years ago, it was unimaginable to have such a dress on public, right? And for example, music also is going to be simplified comparing to the classic, for example, or architecture probably, but I'm not sure that also is simplifying. So some processes go in direction of simplification and another in direction of complexification, right? And what is your predictions? What will simplify in our life and what will be more complex? Thank you.
And
Yeah.
again, before answer, it is difference between complex and complicated.
Yes,
Another
that's
thing. Yeah, sorry.
That's true. So I'm not sure if I can make predictions, but this is I think this is a good point, and this is also a point about being careful. What are our definitions and not also not taking these definitions as a value judgment, but thinking about what is a useful definition for some purpose. So, for example, actually, the dress is a very interesting example because you might say all of us are dressed a similar and simpler style than in all times. But I would guess that our clothes were made in many different places, in many different countries far away. So in some way, we present more diversity, maybe in terms of supply chains, than compared to maybe 30 years ago, when you would still go to a local tailor and ask to fix up your jacket. So even that, but I'm not trying to be to argue for the sake of arguing, but just to illustrate, there is much to think about how we define, and also what Yuri said about complicated versus complex. And what I would say more seriously, that you made a good point, that of course tendency is just a tendency. It doesn't mean everything has to become more complex, and it doesn't mean there couldn't be some things getting simpler, or it doesn't even mean that globally complexity cannot decline at some point. And this is something that comes up sometimes in debates, that someone brings up a counter example and not understanding that we are only talking about tendencies. And I think when thinking about complex systems, we only can talk about tendencies and always have the possibility for trend reversals, and think about that. Think about what might bring trend reversals.
Thank you. Some other questions? One more question from the audience.
Thank you. You mentioned that about complex system, and what is characteristical for a complex system is that the parameters which describe the behavior of a system as a whole are different. They are not the same than the parameters which describe subsystems, microparameters. So I guess perhaps we speak about cells, and this is a large system, complex system, Europe, region in Europe. And could you build a precise separate two separate lists of the parameters which describe a system as a whole? I saw only cycles, they are historical cycles, and another absolutely different list of other parameters which describe the behavior of elements of the system. Thank you.
Yeah, thank you for the question. So actually, I think what I can say is there is a difference when thinking about the system itself and the model. So when you think about the system itself, this high-level view you cannot easily argue about large-scale or emergent behavior by looking at local-scale interactions. This is a general picture. But when we are trying to do a model, often what we want is have parameters that only describe local interactions, but lead to emergent phenomenon on larger scales. So I don't want to put in my model that I want population synchronously growing or declining in a 500 kilometer by 500 kilometer region. I just want to put in what happens in one village or between neighbor villages or villages in a small distance from each other. And if I did my model well, then the large scale pattern will emerge and match what we see in reality. So I would say that in the case of model, it is a tool to connect the small scale individual interactions to the large scale ones, even though the outcome might not be very intuitive. I'm not sure if this answers what you if this answers your question well enough, or maybe you can follow up.
Thank you.
Thank you.
Thank you.
Thank you. Yeah, one more question, please.
Thank you very much for your very interesting lecture. But I have very simple question. You discuss about simple and complex systems, but it is well known that exist linear and non-linear systems. It is true that linear system is simple, but non-linear system is complex. It is the first simple question. And the second, it is well known that in non-linear system exists so-called stochastic resonance, when very small changes of some parameters caused very strong changes of values which describes the behavior of system. Do you use concepts of stochastic resonance for the explaining your results? Thank you.
Thank you. So as a physicist, I like this characterization of simple and linear systems and non-linear and complex systems. So in many cases, complex systems involve non-linear interactions or non-linear feedbacks. Still, I would say sometimes a non-linearity comes from the interaction of components. So especially if you think of an agent-based model, which I have to admit, this is a big jump because this is thinking about a specific way of modeling things and not the system itself. You can try to build a model or a system where individual components are linear in some way, but the potential for interactions creates the non-linearities, which lead to complex dynamics. Regarding your question of stochastic resonance, so in our model we didn't use this explicitly. What did come up is exactly this question: what if a small change in parameters changes the results. So we did a parameter space exploration, and we exactly to verify that there are parts of the results that change. And of course, the model itself is stochastic. So every run is, every simulation gives different results. But the main outcomes, the main type of outcomes we see are robust across a large range of parameters. So that's something that we know we always have to do, especially when there are nonlinearities involved. And more generally, with any potentially chaotic system, we are aware that there is a limit of predictability. So we have to ask the right kind of questions, and characterizing what questions to ask is also part of the research.
Thank you. No questions from online participants? Also no questions from the conference hall. So I hear some sound. Maybe somebody wants to put a question? No.
Or maybe
No, okay.
someone wrote in chat. I don't see the chat. I don't know if you see it.
I am looking, on the chat,
Okay.
and I'm looking on the list of participants, and I don't see the
Okay.
I don't see the
Very good.
volunteers. Okay. So thank you very much, dear Daniel. It was very interesting, very useful, and I mean, different participants. Some of us are humanitarians, some of us are from natural sciences, and believe me, we all enjoyed your talk. Good luck you with studying our old and not that old history, and thank you very much for coming to Lviv, and we hope to welcome you in future when the right peace comes to Ukraine.
Thank you very much for the invitation and for your feedback. And yes, I hope I can visit you in a more peaceful time. Thank you. Bye.
Daniel, are you still here?
Yes.
I see another question. I believe it is my colleague historian, but his microphone is muted. It is written Yaroslav, and I see the hand, you have raised your hand. Could you unmute? Now he is making me a call. Yeah. Tak, Slavko. So it was Yaroslav Hrycak, Ukrainian historian, I would say, my opinion, and many of us, very prominent Ukrainian historian. And he made a call just to pass you his thanks for your talk. And also he asked whether it will be possible if you share your presentation, also the PDF, for example.
Yes, sure. I will send to maybe to you, Yuri, and you can pass
maybe
along.
To me or to Mariana. Yes. If you don't mind, we can sometimes we put online the talk and also the presentation, and then everyone interested can look. Thank you very much again. Goodbye.
Yeah, thank you again. Thank you, and all the best. And goodbye.